today, I hope that you have this ready. Okay, and I want to remind you all once again that for this chapter, you're going to need a long ruler. Okay, you're going to need a long ruler, and it should be like 30 centimeters lah. Okay, it doesn't matter whether it is a nice one like mine lah, or just the normal plastic ruler, but preferably yang you can see that is plastic lah. Okay, that you can see through. And secondly, you're going to need a lot of graph paper because this whole chapter is about graph paper. And if you don't have graph paper, go and buy. Okay, please go and buy. Otherwise, you're going to miss out on this chapter lah. Okay, and I think this chapter is the one of the easier chapters in Form 4. But again, it is easy only if you participate in the class. Okay, secondly, I hope that you have this module with you because we're going to refer to this module a lot, especially today. All right, so this chapter is talking about linear law. Okay, now we have learned before that when we're talking about linear lines, okay, linear graphs, okay, or linear equations, okay, so linear equation which gives linear graphs, okay, usually will have straight line graphs. Okay, either straight line like this, or it can be straight line like this, okay, or it can be, straight line like this. Okay, so all these are straight line graphs. And so in this chapter, we want to see how we can convert a non-straight line graph into a straight line graph. It is possible. Okay, it's possible for us to do it using mathematics. I give you a non-linear equation. Okay, non-linear means got square lah, got per x lah, all those things. Actually, you can change it into become a straight line graph, but you need to know what are the skills involved. Okay, so the first thing we need to talk about is a graph of linear relation is a graph that forms a straight line. Okay, so if it is a linear graph, then it is a straight line graph. While a graph of non-linear relation, okay, is a graph that does not form a straight line. Anything that is not a straight line is called a non-linear equation or non-linear relation. Anything that is a linear, okay, is a straight line graph. Okay, so in this example that you're given over here, okay, which I want you to do now, okay, so you're given these coordinates. I want you to plot the graph. Okay, so we go back to the basic skill of plotting the graph. So I want you to plot the graph and I want you to join all the lines together. And then after that, you tell me whether it is a linear relation or whether it is not a linear relation. So in your module there, got 3 questions, right? Okay, so I'm going to give you 10 minutes to answer all 3 questions. Those of you who are watching this video from YouTube for ST, okay, also do the same thing. Pause the video and then do this for 10 minutes. So 10 minutes, I want all of you, now, sorry, I'm talking to 4AC. So I want the people in 4AC, go and answer these 3 questions that are in your module. Oh, sorry, you can't see. But anyway, this is the module lah. Okay, so the 3 questions in the module, answer it now, and then 10 minutes, I will call you to answer the questions. Okay, draw the graph now, everyone. Okay, 10 minutes. Okay, so what we're going to do now is, okay, I'm going to give the assignment in the chat now. So you take a look at the chat. I want Benedict, Mechi, and Charlotte. Charlotte, if you sempat lah, okay, Benedict, Mechi, and Charlotte, you take a photo of question number 1 and then you send it into the Telegram group now. Okay, and then Sinbury, Yvonne, and David, you do the same thing for question number 2. And then Freya, Weichen, and Stephanie, you do the same thing for question number 3. Okay, take a photo and post it into the Telegram group now. I'm opening up the Telegram group so that we can all see the answer together lah. Okay, this is David, question number 2. Okay, this question number 2. So David, what is this? Is this a linear or a non-linear equation? A relation. Okay, it's a linear relation. Who is this? This is Benedict. Okay, nice. Okay, Benedict. So Benedict, is this linear or non-linear? Okay, Michi also the same. Oh, okay, Benedict non-linear. Who is this? This is Stephanie. Stephanie, linear or non-linear? Okay, this is very good. Stephanie, is this linear or non-linear? Oh, sorry. Stephanie is typing in the chat. Don't know which chat to type. Okay, fine. Okay, non-linear. Okay, Charlotte is sending a photo. I'm just going to wait for Charlotte and then we'll continue, okay? The rest of you just continue to send now, okay? But I think basically you get the idea. This is the answer for number 2. This is the answer for number 3. And this is the answer for number 1. Okay? Both Nietzsche and Benedict have the same kind of graph. Okay? But basically, all right, question number 3 is non-linear. All right? And we find out that question number 2 is the only linear one. Okay? It's the only linear one where it is a straight line. So this is the first thing we need to understand, the difference between a linear and a non-linear graph. This is linear, straight line. Okay, this is non-linear. Curve lah, got U shape lah, got N shape lah, got S shape lah, whatever shape lah, got circle shape also, all these are non-linear. Okay, but this chapter, if you remember, this chapter is called linear law. Okay, so we are interested in drawing straight lines. Okay, so when we draw straight lines, actually this is what you will get lah. And that's why I didn't want to show you this because the answers are all already here. Okay, so when we do this, okay, we need to, when we draw a straight line now, we need to have a certain skill lah. Okay, so the skill is called a line of best fit. Okay, we come back to our this one now. So I want to teach you how to draw a line of best fit. So a line of best fit can be drawn such that the straight line passes through as many points as possible on the graph. Okay, so this is condition number 1. You want to try to pass through as many as you can on the graph. But, okay, the number of points which do not lie on the line, means the ones yang tidak kena, okay, must be balanced on both sides of the straight line. This is the second condition. Okay, let me show you an example. So the example given over here, okay, I cannot show you the answer. Okay, so this is the example given over here. Okay, notice that in this one, the one yang kena is 1, 2, 3, 4. 4 is the one that's touching the straight line. Okay, how many is not touching? Oh, sorry. How many points are not touching? Can you see? Okay, there are 2 points that are not touching, the ones that are marked green. Now, this is what it means. The ones that are not touching must be balanced on both sides. Kan? So, the green one is on the right side, and then the blue one is on the left side of the line. Okay, so this is what it means by best fit. You try and kena as many as possible, but the one that tidak kena must be balanced. You cannot have both on this side. Cannot. That is not called best fit. It must be as balanced as you can. So the maximum difference that I can allow is a difference of 1. Okay, sometimes when you draw a graph, especially when you're, when you're already going to be doing exam questions, right? Sometimes you will find that the plot, right? Sometimes you will have 2 and then 1. 2 and 1 is okay. 2 on the right side and 1 on the left side yang tidak kena. Okay? Or if you have 2 at the down and then 1 at the up, so tidak kena, can lah. But you cannot have a situation where there is 3 that is up here and then like 3 versus 1. 3 versus 1 cannot. It's too imbalanced already. So you have to take your ruler. Okay, you take a ruler and you have to kind of adjust until you find the most suitable one. Okay, so the same thing. The next 10 minutes, what I want you to do is draw the 3 graphs again. Okay, question number 1, number 2, number 3, and this time you need a ruler lah. Okay, this time you need a ruler because you're drawing straight line, right? Okay, so try to draw the line of best fit. Okay, I'm going to give you 10 minutes to answer all 3 questions in page 90. Okay, page 90 in your module over here. All right, the line of best fit. Remember, try to kena as many as possible. The one yang tidak kena must be balanced on both sides of the line. Okay, this is something new, so let's learn this together. All right, 10 minutes. Okay, everyone, the same thing. So I'm going to post The same, this one again. Okay, question number one, Zhong Han, Yvonne, Wei Chen, and Mei Qi. Question number two, Benedict, Stephanie, Freya. Question number three, Sinbury, Charlotte, and David. Okay, and then let's see how your work is lah. Okay, going over to the Telegram. Okay, let's see. This is Sinbury. Okay. Sinbury is question number three. Okay, let's take a look. It looks like everything kena. Okay. Okay, Sinbury, can you do something a little bit extra? But everybody also lah. Okay. What I would like you to do is I would like you to extend this further, and then can you just tell me what is this coordinate over here? Okay, mark it down in your this one. Okay, mark it down in your paper, and then tell me what is this the y-intercept over here. Okay, there is a reason why I do this. Everyone also the same. Okay, all your graph, extend your graph until it hits the y-axis, and then tell me what is the intercept over here. Right down at the side lah. Okay, negative something 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 something. Okay, yeah, this card all changes. All right, next person. Who is this? It's Yvonne. All right, Yvonne is question number one. Okay. So Yvonne, question number one. Never mind, we look at it from the side. Okay. So Yvonne, this is a good try. Okay, except that you see, got 1, 2, and 3 on the same side. Yeah, 1, 2, and 3 on the same side. So this is not considered best fit. Okay, best fit is you must have balance on. If you have 3 points that tidak kena, 2 on one side, 1 on the other side. You cannot have 3 on the same side. Okay, can you try again, please? Okay, good try, good try. Y-intercept is -3. Okay, so mark it down there. All right, let's see. This is Benedict. Benedict's question number 2. Assuming that your straight line is good, okay, so the good thing is, oh, sorry. So the good thing is 1 on each side. Okay, so this is a correct graph, except that ruler. Hello, no ruler. And then, 跟我讲, this is how much. Can you tell me how much this is, please? Okay. All right, let's see who else. Everybody. Sir, I don't have ruler. Please, I have ruler. Okay, -6. Okay, so you see Charlotte, everybody, see Charlotte's answer. So this one tidak kena, this one tidak kena. Okay, but it's balanced on both sides. And so 1 on each side. Okay, so I would say this is correct. And the -6 is also correct. Okay, good job. All right. So let's see who else. Who is this? Wong Zhong Han. Zhong Han sir, number 1. Okay. So you see this is the problem. So number 1, you can't. Okay. So first of all, oh no. Sorry. Okay. First of all, there are how many points in tidak kena? 1, 2, 3. But the good news is there is 2 on this side and there is 1 on this side. So this one is okay. Okay. For me, it's the best fit. So Zhong Han, can you tell me what is this value of the intercept here? Okay, tell me the value. So different people may have different lines. Okay, and sometimes your line will be a little bit different. So your y-intercept is a little bit different, and that's okay. All right, because it depends on how you draw your best fit. So not everybody is going to have the same line, but it cannot be such a big difference lah. Okay, got small difference in it, but can one. Okay. All right, let's see who is the next person. Who is this? This is Stephen. Wei Chen. Okay, Wei Chen has the same thing as Zhong Han, right? Okay. So this graph, I think to me it looks okay, except that again, tell me what is the y-intercept. Okay, mark down here 1.5. Oh, okay. No, really, 1.5. Okay lah, 1.5 lah. Okay, never mind lah. This is just for practice purposes. All right, let's take a look. Anybody else? 1, 2, 3, 4, 5, 6. So far, 6 people have handed in. Okay, but never mind. So the idea is there. We have all this already lah. Okay, so what I want to do next is okay, so first thing we learn is linear relation. 第二个是 the second thing is how to draw the line of best fit. Now the third one is how to do the equation. Okay, how to write the equation of the line of best fit. Okay, so we come back to all straight lines. All straight lines is y equals to mx plus c. Okay, y equals to mx plus c. So the one that you must substitute, okay, the one that you must substitute is the gradient and the c. Okay, so how do you find the gradient? Same thing, you take 2 points and then you use y2 minus y1 over x2 minus x1. Okay, and then the c, c is the y-intercept. And y-intercept. So just now, some of you got the y-intercept is is equals to 1.5, right? So it's actually y equals to mx plus 1.5. Okay, just now remember I asked you to tell me what is the y-intercept. So you just put that number inside from your graph. Okay, Sinbury's one just now was -6, right? So y equals to mx minus 6 or plus -6 lah. So you get y equals to mx minus 6. But now the problem is I want to find the value of m. Okay, so how do I do this? Okay, so first of all, I'm going to use this example to help you lah. Okay, first of all, what I want you to do is I want you to choose 2 points. Okay, choose 2 points that kena lah. Don't choose the one that tidak kena. Okay, so I'm going to choose this point and this point. Okay, so this one is 1 and 33. Okay, and then this one is 4 and 4. Okay, so 4 and 4. Okay, now this one, the y-intercept is 40, 41, 42, 43. So the y-intercept is 43 lah. Okay, now we calculate the gradient. So gradient equals to 33 minus 4 over 1 minus 4. Okay, 33 minus 4 over 1 minus 4. Okay, remember the second one must be the second one, the first one must be the first one. You cannot just simply change as you like. Okay, so 33 minus 4 will give us 29 macam. Okay, so 29 divided by -3. Okay, which will give me, hold on. Okay, will give me -29 over 3. Okay, give me your answer in fraction. Okay, and then after that we put into the equation of the straight line. So you write like this lah. Okay, sorry. Okay, so the equation of straight line is y equals to, how much is my gradient? My gradient is -29 over 3. So I write lah, -29 over 3 x plus, what is my y-intercept? 43. Okay, so I write 43. So this is how we write equation of straight line. We find the gradient, we determine the y-intercept, and then you just substitute it into y equals to mx plus c. Okay, the y and the x, just leave it as it is. Okay, so this one I'm going to give you 5 minutes because everybody already has a question now. So we're going to use the same one. Wong Zhong Han, you find the equation of the, Wong Zhong Han, Yvonne, Wei Zhen, and Mei Qi, you find the equation of the straight line for question number 1. Benedict, Stephanie, Freya, you find the equation of the straight line for question number 2. Sinbury, Charlotte, and David, you find the equation of the straight line for question number 3. Take a photo and send it into the group again. Okay, write it like how I showed you lah. Okay, this one 5 minutes only, 5 minutes, not so long. All right. Okay, looks like Charlotte has already got her answer. Y equals to 9x minus 6. Can Sinbury and David verify this? Is the gradient 9? 25 over 2x plus 3 over 2. Wei Zhen is which one? Oh no, this is not. Wait. Which one is this? Oh, this one. Okay, the 3 over 2 is correct, but I'm not sure about the 25 over 2. 19 over 2x minus 3. Doesn't Sinbury and Charlotte have the same question? Yeah, Sinbury and Charlotte has the same question. So how come how come your equation is different? It's not just different a little bit, no, it's different a lot. Or 19 over 2 is 9.5. Okay. No, but yours is minus 3, you know. Charlotte's is minus 6, you know. Oh, minus 6. Let me see Sinbury's one. Wait, Sinbury. All I can see is, sir, I don't have ruler. Sinbury. Are you sure that's minus 3, Sinbury? ES answer. Yeah. Are you sure that's minus 3? It doesn't look like minus 3 to me, though. 23 over 50. Sinbury, Charlotte, and David, you have the same graph, but 3 different answers. Okay, David is definitely 错了啦, because you're number 3, right, David? Y equals to 2.6 over 31.2. Song Han, I don't think you can do that. You need to give me a sorry. Can you snap a photo of your this one, Song Han, and let me see how you calculate the gradient? Okay, now the question is now the question is Sinbury and Charlotte. Huh. Are you sure it's minus 3 or minus 6? Can you double check again, both of you, Charlotte and Sinbury? Or minus 5? Okay, fine. Minus 5, minus 6, I can still accept. Minus 3 is too far. Lah. Okay, so I think Charlotte's answer is probably the most accurate. Lah. 9x minus 6. But again, like I said, it depends on how you draw your best fit. Okay, but the difference is not so much. Lah. So Sinbury, your gradient is 9.5. Charlotte, your gradient is 9. No problem. Sinbury, your y-intercept is minus 5. Charlotte, the intercept is 9 minus 6. Okay, also no problem. A very small difference. It cannot be minus 6 and minus 3. That one's too big of a difference. Okay. Chong Han, can you show me how you did your gradient again? I have yet to hear from question number 2. Benedict, Stephanie, and Freya. I still haven't seen question number 2 yet. Okay. 3.6 minus 1, 46.2 minus 15. Wow, how you get 3.6 minus 1? This is who? Zhong Han, number 1. 3.6 minus 1, 46.2 minus 15. Okay. Zhong Han, I know what's the problem already. The gradient is y2 minus y1 over x2 minus x1. Kan? These are the values of x. These are the values of y. Okay, do you see where that mistake is? Okay, can you try again, Zhong Han? Okay, question number 3, I think got it already. Question number 1, so far only Zhong Han and Ng Wei Zhen. Ng Wei Zhen is 25 over 2x. Yeah, I think Ng Wei Zhen is probably correct. But let's see what Zhong Han says. Question number 2, ini. What happened to question number 2? Where is the people who are doing question number 2? Why are they silent? You will probably get a negative gradient, and it's okay. Okay, it's okay to have a negative gradient as long as you calculate correctly. 12x plus 2. Let me see. Wei Zhen's one is 25 over 2x plus 3 over 2. Okay, yes. This is a much better answer. Okay, 12x plus 2. So, Wong Zhong Han, remember, when you calculate the gradient, y is on top and then x is at the bottom. Okay? All right, question number 1 settled. Question number 3 settled. Now question number 2. What happened? Benedict, Stephanie, Freya, any feedback, any answer for me? Y equals to minus 10x plus 41.5. Okay, Stephanie, can you take a photo of your work and show us, please? I think it's probably correct lah, but I just want to double check. Can you show us your work? How about you? Sorry, is Freya still here? Freya, okay, Freya is still here. How about you, Freya? Are you okay? All right, let's take a look at Stephanie's one. So she used 11.5 and 1.5. Okay, 3 and 4. So you get minus 10. Okay. So this one okay. So this one I want to comment I want to comment about this because in this chapter, okay, okay, in this chapter we want to use the value that is in the graph. So I know why you did this because this is from chapter 5, chapter whatever lah, chapter 5 I think. Yeah, coordinate geometry. Can we substitute the y and x and then we get the m and then we get the c lah. Okay, but in this case, cannot. We have to use the intercept that is in the graph. So how much is this intercept? Sorry. Okay, how much is this intercept? 31, 32, 33, 34, 35, 36, 37. Okay, so your answer should be y equals to negative 10x plus 37. This is from calculation. Okay, but in this chapter, we want to take our answer from the graph. So this is the big difference about this chapter and coordinate geometry. We look at the graph and the graph tells us the information. So if you draw the graph and you say it's 37, 37 now, we have to use 37. Okay, so this is where we learn from our mistake. Okay, so I'm not sure what happened to Benedict and Freya. Okay, so what Stephanie did was she chose these 2 points, 11.5 and 3, 1.5 and 4, which is 第四跟第六. Okay, the 4th and the 6th point. Also can, okay, also no problem. Except that Stephanie, remember, we use the information from the graph, no longer from calculation. Okay, we cannot use calculation already because this is linear law. Okay, and if we draw a graph, we must get our information from the graph. Okay, is that clear, everyone? All right, so let me show you the graphs again now. Okay, so you see from this graph, okay, so what you drew just now is about correct lah. This is 37. This is about 1, 2, 3, 4, 5. Okay, it's about negative 5. Okay, and this one, number 1, is 1, 2, 3. But some people 2 and some people 1.5, right? Again, like I said, different people will have different meanings of the best fit. Okay, the most important thing is you remember the 2 rules. Try to connect as many as you can. And the second one is the one yang tidak kena must be balanced on both sides. Okay, and then remember how to calculate the gradient. Remember, the y coordinate is on top and then the x coordinate is at the bottom. And then finally, when we do the equation of the straight line, okay, we take the value of the gradient and we take the value of the y-intercept from the graph. We don't calculate the y-intercept. Okay, this is very special for this chapter. We must remember this. Okay, because later on we're going to draw a lot of graphs. Okay, and I want to make sure that you have these skills in hand. How to draw best fit, how to find the gradient, how to determine the y-intercept, and how to do the equation of the straight line. So what I want you to do today, okay, to prepare for Thursday's class. Tomorrow we have no class. Tomorrow is public holiday. Okay, so to prepare for Thursday's class, I want you to answer all the 3 questions in exercise 4. Okay, so the question is all the same one. Plot a graph and then draw the line of best fit. Okay, what we did just now. And then after that, determine the y-intercept and the gradient. Okay, so in this case, they draw already. You see, okay, is this best fit or not? Let's look. 1, 2, 3. Actually, it's not best fit, Kan? Because this is 3 and then over here is 0. So actually, there's something wrong with this answer. You can find a better best fit one. 3, 0, the one. Okay, 2, 1 or 1, 2, can lah. Okay, no problem. But 3, 0 is a bit too much, not good. All right. So, but the point is this lah. After you find the gradient 0.46, and then you look at the y-intercept. The y-intercept over here is 5, 6, 7, 7.5. Okay, and that's how they get the answer 7.5. And then Stephanie, look, the y-intercept, they just substitute in. No finding the y-intercept using calculation. We use the graph to help us. Okay, so question number 1, number 2, number 3, I cannot show you because the answer is inside this module. So question number 1, number 2, number 3, okay, I want you to answer this question, and then on Thursday, oh, my next class is with 4ST. Okay, fine. So those of you in 4ST, okay, on Wednesday, okay, I want to see this graph, all the 3 graphs in your module, okay, and I will ask you to post it up in the group so that we can see. For all of you who are in 4AC, since your next class you're going to be watching the video, okay, you use the video to help you, but make sure that you answer the question first. Okay, don't wait for the video then only answer the question. Okay, so remember the skills we've learned today, especially how to draw best fit.